All right, today on Die Hard American Metal, we are forging right into the heart of American manufacturing. We're going to look at a technology that is, and I'm not kidding, rewriting the entire rulebook for working with the toughest metals on the planet. It's called Precision Electrochemical Machining, or PEC for short, and believe me, it is a total game changer.
But first, let me just ask you this, kind of set the stage here. How in the world do you machine the toughest, hardest metals out there without even touching them? I mean, how do you cut and shape something like tool steel with microscopic precision without any physical contact? It sounds like something straight out of science fiction, right? Well, it's not. It's happening right now, and we're going to break down exactly how.
Okay, so to really get a grip on why this new tech is so revolutionary, we've got to first look at the old guard, the titans of the industry. For, decades, there have really been two heavyweight champs that have dominated the world of precision metal cutting.
So in one corner, you've got high-speed milling. Think of this as pure, unadulterated brute force. You have a super hard cutting tool spinning at insane speeds, just physically tearing and shearing metal away. Then, in the other corner, you have sinker EDM. Now, EDM stands for electrical discharge machining, and it uses thermal force. It's basically a controlled erosion process, using thousands upon thousands of tiny, high-energy sparks to literally melt and vaporize the material. So you've got mechanical force versus thermal force. And don't get me wrong, both are incredibly powerful ways to shape metal. But, and this is a big but, all of that force comes with a hidden cost. Milling, for instance, puts a ton of mechanical stress into the part, and it just chews through tools. They wear down like crazy. And EDM, with all that intense heat, it creates something called a heat-affected zone, or HAZ. It's an area where the metal's fundamental properties actually get changed. Worse, it leaves behind this hard, brittle skin called the white layer. So you see, both of these powerhouse methods, they push the material right to its breaking point and leave a trail of microscopic damage behind.
So that brings up a pretty wild question, doesn't it? What if you could machine metal without any force at all? No stress, no heat? Well, it's time to meet the new challenger. This is a technology that completely throws out the old rulebook. It doesn't work with brute force or intense heat. It works with the fundamental laws of chemistry.
The magic behind this is a process called anodic dissolution. And I know that sounds complicated, but stick with me. Forget everything you know about cutting or melting metal. PECM uses a simple saltwater solution, an electrolyte, and a very controlled electrical current to literally dissolve the workpiece atom by atom. The best way to think about it, it's like hyper-focused, precisely controlled rust, but happening at an absolutely incredible speed. No touching, no heat, just dissolving. Now, here's the part that is just mind-blowing. This is what makes it a revolution. Because PCM is a purely chemical process, the hardness of the metal is completely irrelevant. Let me say that again. It doesn't care how hard the metal is. A super hardened piece of tool steel, the kind that would shatter a traditional milling cutter into a million pieces, it dissolves just as easily as a soft piece of copper. That one fact right there just completely shatters the old limits of machining. It changes everything.
Okay, I know what you're thinking. If you're just dissolving metal away with salt water, how in the world do you control it? How do you get that micron-level precision to create really complex shapes? Well, the answer lies in a brilliant piece of engineering, a kind of power piston.
This is the absolute heart of the machine right here. The tool, which is called a cathode, is actually oscillating. It's moving toward and away from the workpiece at an incredible speed. So step one, it moves in, squeezing out the old salt water. Then, and this is the key, when it gets unbelievably close, we're talking a gap thinner than a human hair, a high-current electrical pulse fires, zap, and it dissolves a super precise layer of metal. Immediately after that pulse, the tool retracts, and that motion sucks in fresh salt water, flushing away all the dissolved material and any heat. And this whole cycle, it happens over and over, sometimes 60 times every single second. It's incredible.
All right, now for the main event. Let's put this new technology head-to-head with the reigning champ for making complex parts, sinker EDM. This is the ultimate tech showdown.
So let's look at the tail of the tape here, and wow, the differences are just stark. You look at surface integrity. EDM leaves behind that damaged, brittle white layer, while PCM leaves a totally pristine, stress-free surface. Now look at tool wear. EDM electrodes, they're consumables. They wear out fast and you're constantly replacing them. But a PCM cathode, it has virtually zero wear. It's not sacrificial. And what's the bottom line for production? Well, PCM can be 5 to 10 times faster, and it produces a mirror finish right out of the machine. No secondary polishing needed.
It's not even a close fight on these metrics.
And really, this right here is the knockout punch. That white layer we keep talking about from EDM, it's a huge weakness. It's a super hard, brittle skin that's just prone to cracking under stress. And those cracks lead to premature tool failure. PCM, by leaving the material's original grain structure totally intact, well, it produces tools and dies with a vastly superior fatigue life. What does that mean in the real world? They just last longer, a lot longer.
So you might be wondering, where does a radical technology like this actually shine? Where does it really dominate in the real world? Let's take a look at a few examples where PCM is the undisputed champion.
Okay, let's talk about making the dies used to stamp coins. The old way is called hubbing, and it's a brutal, multi-stage process. You're literally using immense pressure, hundreds of tons of force, to press a hardened master into softer steel, then hardening that, and so on. And every single time you do that, you lose a tiny bit of detail. PCM just throws that whole process out the window. You use a single master cathode to directly machine thousands of working dies, and every single one is a perfect first-generation clone of the original. Total disruption.
And the scale of this advantage is it's staggering. Just look at that number, 10,000 plus. That's how many identical, flawless parts you can make from a single tool, a single cathode. Why? Because there's zero wear. That kind of perfect repeatability is something you just can't get with traditional methods, where the tool itself is literally degrading with every part it makes.
And in the world of high-volume injection molding, this advantage just gets multiplied. With PCM, you can do what's called parallel processing, machining 4, 8, even more mold cavities all at the same time. And because there's no tool wear, cavity number 1 is a perfect twin of cavity number 64. They are identical. Plus, you can create these crazy geometries, like super deep thin ribs with aspect ratios of 20:1 or more. A traditional milling tool would just snap clean off trying to do that.
But this might just be its most impressive feat of all, unlocking tungsten carbide. This stuff is the final boss of hard materials. It's incredibly tough, incredibly wear-resistant. But if you try to machine it with EDM, all that heat causes thermal damage, it can leach out the cobalt binder, and it basically weakens the material. PCM, on the other hand, can machine complex 3D shapes right into solid carbide without causing any of that damage. The tool comes out with its full, uncompromised strength.
Okay, so all of this revolutionary power, it has to come at a price, right? There's got to be a catch. So what does it actually cost to wield this kind of manufacturing power? Let's talk about the investment. This chart here lays out the strategic trade-off perfectly. On the one hand, a sinker EDM machine has a lower upfront cost. That's the CapEx, the capital expense. But its day-to-day running costs, the OpEx, or operational expense, are high. You're constantly buying electrodes, you've got labor for polishing, it adds up. Now, look at PCM. It's the exact opposite. The initial investment, the CapEx, is high, no doubt about it. But the operational costs are incredibly low because you have zero tool wear. So for high-volume, long-term production, PCM absolutely crushes EDM on the total cost of ownership.
So let's be really clear here. What's the final verdict? PEC is not going to replace every milling machine or every EDM out there. If you're just making a one-off prototype, it's probably not the right tool. But for the toughest jobs, for high-volume manufacturing where you need extreme complexity, perfect repeatability, and the absolute best material integrity, for those jobs, it is an apex technology. It's just in a class all by itself.
When you really step back and look at it, PCM is so much more than just a new machine. It's a whole new rulebook for manufacturing. It unlocks geometries, materials, and production efficiencies that were literally impossible before. It represents a fundamental shift, a massive competitive advantage just sitting there, waiting to be claimed. So the only real question left is, who's going to be the one to pick up that new rulebook and use it to dominate the future?